Right, welcome to COMP3311 database systems. I may not be the lecturer, but I'll be the person who's doing all of these videos. So, what's this course all about? Well, clearly it's about data. And it's about systems that manage data and not just a small number of structs, like you might see in a C program, but extremely large amounts of data, and they have to manage it efficiently. So we'll often draw database systems as looking like a big fat disk, something like that. And there'll be data, and there'll be a system that manages that data. So often we'll call the data itself, the collection of data that we're manipulating, the database, and the system that manages it we'll call a database management system. Surprise, surprise. So what do database management systems actually do? One thing they do, they store data, clearly, and they manage the storage of that data. The other thing they do is they allow you to manipulate data, which means insert new bits of data, modify existing data, delete data, and also ask questions about the data. And the final thing they do that's quite important and maybe doesn't get emphasised enough is that they check the validity of the data. So we've got data storage, data manipulation, and checking data validity. So that's what a DBMS does, in essence. All right, we talked about data. What kind of data? Well, in this case, we're dealing with relational data. And basically what relational data is, it's simply a huge collection of tuples. And a tuple's got some number of values stored in it, and in the relational context, a relation is simply a set of tuples, all of which have the same structure. There are other kinds of data that have come into vogue in the last 10 years, things like graphs and so on. They're not going to be the focus of this course. We'll mention them briefly towards the end, but the primary focus is on relational data, which is by far the most widely used kind of data. Every bank, every airline booking system, every student record system is using relational data. Okay, so we need to be able to store, manipulate and check data. How do we do that? Well, the basic idea is that there's a language that was defined quite a long time ago, SQL, which stands for Structured Query Language. So that was defined in the 70s, basically as a way of describing how you want to store and manipulate data and how you wanted to ask questions about the data, which I guess I'd count as manipulate. So Structured Query Language. To use that, you need a database management system. In this course, we're going to use two specific database management systems, which are quite different in what they aim to do. The first one I'll call Postgres, and just ignore the QL at the end. That's how it's normally written. It's a substantial database management system which addresses many of the important properties that other commercial systems like Oracle address. It's an open source system, so if you want, you can download the source code, install it on your machine and play with it. And read the source code if you really want. If you want to read the source code and you want to play with the source code, that's a different course where we'll deal with that. The other database system that we'll use is significantly different to that. It still is quite powerful. It has a fully developed SQL language. It has good data manipulation, and it does a good job of checking data validity, but it's designed not to be a very large system accessed by tens of thousands of people at a time, which is what Postgres can do. if you want, but the other system that we'll be looking at is a system called SQLite. As you can probably guess from the name, it's a relatively lightweight database. And in fact, the idea is that you can embed SQLite access stuff inside your programs and have the database sitting on the disk as a single file. Postgres, on the other hand, structures a database as a directory containing many, many, many files, one file for each relation. Okay, so they're the systems, the DBMSs that we'll be looking at in this course. A lot of stuff will be done using the SQL language. What do we actually do in the course? What topics do we cover? Well, one very important one, if you're going to have a database, you need to have a model of the data. And the first part of the course is going to be discussing data modeling. So what's a data model got to do with the database? Well, it describes the structure of the data in the database. Where does it come from? It comes from the requirements of the application. So normally you build a database because you want to solve some problem, like you want to maintain student records, or you want to run a bank and manage all the accounts. So you'll describe a set of requirements, come up with a way of modeling all the data to meet those requirements, and express that data in the SQL data definition language, and then you can build a database. The next thing, which is kind of what everyone tends to think about, is querying. So once you've got data loaded into a database, you don't want it to just sit there. You've got to ask questions about it. So for example, a student comes along and they want a transcript. We go to the enrolment data, we find what all their marks are, and we can display them. So that's the way that most people interact with a database. And I guess I should have said that most people do not interact using SQL. Generally, the database is going to be hidden behind some kind of either program interface or a web interface. But somewhere behind that interface, there's some SQL going on to do the querying needed to drag up the data that can then be displayed in the web browser or whatever. Speaking of applications that use a database, another very important thing that we'll look at in this course, and which doesn't tend to be covered in a lot of database courses that I've seen from other universities, is the interface between programming languages and the database. So SQL is nice, but it's not a complete solution in itself. It needs to be wrapped in an application programming language like Python or PHP or Java or even C. And so there has to be some kind of interaction between the database and the programming language, and I'll talk about that in another video. In fact, I'll be talking about all of these topics in more detail in other videos. So these are the kind of skill parts of the course. So we expect you to be able to build data models, we expect you to be able to write queries, and we expect you to be able to implement an application using a programming language that accesses the database. Other interesting things that we'll be looking at is the notion of functional dependencies and normalization. So I'll just write FD for functional dependency. If you forget what that means, doesn't matter, we'll be talking about it in more detail. And normalization. And basically what these topics are all about is deciding whether a data model that you've built is in some sense good. A good data model has minimal redundancy, so it's quite possible to build a data model where you store lots of data in multiple places, lots of the same copies of a piece of data in the same places. The idea with functional dependencies and normalizations is to try and minimize that as much as you can. There's a lot of nice mathematics that go on with that, and in fact I should have probably pointed out that the SQL data model was the the relational data model is a mathematical model, and it's a really nice example, one of the nicest examples in computer science, I think, of a context where a mathematical model of some computational process, maps very nicely onto an actual implementation. And there's a lot of work that goes on in the background to make that mapping work efficiently, but there's a relatively short distance between SQL and the relational model. And it's quite interesting that such a simple model, just collections of tuples, works so well in so many contexts. There are some contexts where it doesn't work that well, and that's one final thing that we'll take a look at right towards the end of the course, if we have time, is non-relational data. So nowadays there's a lot of work done using data that's essentially graph structured. Now you can represent graphs using SQL, but it's not quite as natural as a lot of other data like student records. So we'll be talking a little bit about other kinds of data that's coming down the pipeline, if you like. And there's quite different database management systems that have been developed for this kind of data. So that's an overview of what we're going to cover in 3311, and I hope you enjoy what you encounter in the rest of the course.